Alright, okay, so welcome back, dears, sa atong pre-recorded lecture on precipitation reactions. From the last lecture, no, we ended on law of mass action and the difference between affinity and avidity. So, ang important yun is the avidity because again, it's the overall, no, the sum of all the attractive forces. Yes. So, muna siya, guys, if you have relationships there, mga may jowa dyan, jowa. Sana all. Yes. Strong ba yung avidity? Shucks! So, don't settle for affinity, no? Always aim for avidity. Okay, alright. Ayan, so dili tagana na ng fleeting na attraction, na dili strong like affinity. We want the long term, the strong, the overall force. Strong overall force na long term avidity. Yes, that's our end goal. Charot, okay? Alright. Daming chika, yung mga hugot para lang talaga may mahugot dyan. Okay, anyway. Alright, so we'll continue now with our lecture starting with precipitation curve. So, dili ra sa COVID cases na i-curve, guys. Dapat sa precipitation curve. So, kanya siya na curve, no? Dili taganahan na i-flatten siya. Ang COVID-19 cases dapat siya ma-flatten. But 1 year na lang, wala pa dyan na flatten na ng curve. Yes, so, sino may sala dyan? Yes, alam niyo yung answer. Okay, charot. Okay, alright. So we'll start first with precipitation curve. We'll now go with precipitation curve. Again, a curve that we don't want to be flattened. Alright. So this curve shows the amount of the precipitation that varies with varying antigen concentration. So ang antigen atong gi-vary, and then ang antibody concentration ang constant. So example, this is your curve. O, di ba? Perfect curve, no? A normal curve, yes naman. Okay. So increasing ang antigen concentration and your concentration of antigen-antibody complexes ang naasa mong x-axis. Alright. So for the first part, as you can see, the red ang antigens, no? So gagmay ang antigens, pero daghan ang antibodies. Now this portion is what we call the prozone. Okay? Prozone. So pro first. Alright? Alright. Then the middle, as you can see, no, equal ang number of antigens, equal po ang number of antibodies. So they form what we call a lattice. Alright? So they form a lattice, or mag-connect sila sa each other. Alright? This is now what we call the zone of equivalence. By the name itself, equivalence. Equal ang number of antigens, equal po ang number of antibodies. Alright. Ayan. And of course, the last part, nagkadaghan ng antigens, gagmay ng antibodies. As you can see na yung ibang antigens na wala na bind, this is now what we call the postzone. So as you can see, zone of equivalence. So before the zone of equivalence is prozone, and after is of course postzone. All right? Okay, ayan. Now we go now to the different areas of the curve, no? First is of course the zone of equivalence. This is where optimum precipitation occurs. So when you say optimum precipitation, this is the maximum precipitation na mahitabo, because again, this is where the number of multivalent sites of antigen and antibody are approximately equal. Alright? And because of that, equal sila, so meaning each antigen na ay antibody na mabind, alright? Or ang sites rather di ay sa antibody, na ay ma-fill siya by the sites of the antigen pod equally. Alright? So therefore, each antibody binds to more than one antigen, because again, multivalent man, and vice versa, alright? And they now combine to form a stable network lattice, ayan. And this lattice hypothesis is based on the assumption, again, that each antibody binds more than one antigen, and that antigen, example, each antibody binds to more than one antigen, and this antigen also binds to another antibody, ayan, binds to another antibody. Wait lang, Mark, nagkakamali ka na naman pag-drawing, baka may ma-drawing ka na namang mali. Ayan, tama, ayan. So now they form a lattice network. So, na-combine sila together. Sorry guys ha, pagpasensya na ang drawing. I'm not an artist. sorry. Sa akong last sem yun, sa back 10, ako yung mga na-draw na mali. So, di na ako mapatakag drawing kaya mahadlok na ako magkamali. Baka ma-issue. Charot. Anyway, alright, so, stable network lattice. Muna siyang point. Equal man sila, no? Multivalent sites of the antigen and multivalent sites of the antibody. So, mag-combine sila together. Ayan, mag-connect sila to form a lattice network. Alright? Alright. And this multimolecular lattice grows in size until they precipitate out of solution. Okay. Alright. Ayan, so that's for zone of equivalence. This is the zone that we want, no? Because again, this is where precipitation occurs. Kaya equal ang sites tanan, alright? And then, each antibody, multivalent sites of the antibody have antigens na pwedeng mubind, alright? Ayan. And the antigens also, multivalent antigens, have antibodies na makabind sa ilang sites, alright? I hope na gets lang. Now, we go now to what we call the prozone, alright? So, prozone, unsa gani ang situation, Annie, there are a lot of antibodies but little antigens. So antibody exists, all right? No lattice or crosslinks are formed. Because again, only one side of the antibody molecule is used because gagmay rang antigen. So, kinsa may mo bind sa other binding site sa antibody. So, example, this. So, as you can see, gagmay rang antigen. So, na-complete niya. Pero gagmay rang antigen. So, dili sila ka-form og network. Kaya wala na mo combine any other sites sa antibody. Alright? So, that's antibody exists. Daghan na kay kang antibodies. Alright? Now, the dilemma here is that it causes false negative reactions. Because again, walay precipitation na mahitabo. And usually in precipitation reactions, the presence of a precipitate, alright, is of course considered a positive reaction. Now, if walay precipitate na mahitabo, because again of too much antibody, walay na hitabong network, lattice network na nahitabo, so it causes false negative. Alright? Kay false negative siya. Alright? Kay so it's supposed to be positive, the antigen is there or the antibody is there, pero wala lang siya na-detect sa imong test because again, too much ang antibody. Alright? Okay? So, munang false negative. Okay? Alright. And lastly, corrective measure is what we do. We dilute the antibody because again, it's too much. So, ato siyang i-dilute para at least mo gamay ang number of antibodies in a way para ang number of antigens na naa and the number of antibodies there are approximately equal, di ba? Para ma-achieve na to ang zone of equivalence. And then they can now form a lattice network and then precipitation will now occur. Alright? Okay, that's Prozone. So, sige, yun na lang ako mnemonic. Okay, alright. I think naba ko yung mnemonic, Ani. And the last zone is the Postzone. Okay, by the name itself, it's antigen exists. Still the same situation, no lattice or cross links are formed. So every available antibody site is bound to a single antigen. So ayan, as you can see, daghan pang antigens na wala na bind. Alright? So napay mga antigens na wala na bind. So what it happens is, of course, wala dyan po yung lattice network na mahitabo. Kaya na may antigens na too much or na-excess. Alright? So what we do, our unsayang dilemma, it's still the same, false negative. So as you can see, both Prozone and Postzone cause false negative reactions. So lumalabas sa boards, I think, if you are to be asked also, what is the cause of, or what is the result of a Postzone and a Prozone? It's the same na silang duha, false negative. Why, sir? Because again, no lattice network is formed. Walay precipitate na mahitabo. Walay precipitation na mahitabo. So therefore, walay precipitate na makitaan, alright? So therefore, false negative. Okay? I hope you understand. So both of them cause false negative. Alright? Please take note. Alright. And on sa atong corrective measure, we retest the sample. Or, example, ang patient, ato siyang ipabalik after a week because unsay rational, it already let the body develop more antibodies. Ayan. Which gives time for further antibody production. So at least, again, ma-even out, ma-equal ang number of antigens and antibodies, they can now form a lattice network. Alright? Again, which is what we want sa zone of equivalence. Alright, so again, Prozone, Postzone, unsay lahang main results? False, negative. And aside from that, unsay lahang mga corrective measures, okay? For Prozone, since daghan mang antibodies, you dilute the sample, alright? Para mugamay in a way ang concentrations sa antibodies, para ma-equalize, alright? And for Postzone, unsa to ang corrective measure, we retest the sample a week after, alright? Maybe a week or two, ana. Because again, the rationale is that more antibodies will now be produced. Alright? Okay. Para at least mo equal na ang number. Alright? Okay. So, again, sa akong mnemonic, ana, for Prozone, daghang antibodies. How do I remember? Okay. Okay. Alright. Prozone, antibodies and antigens. So, asa may mas mauna? Ang letter B or ang G? Ang letter B. So, siya ang daghan sa Prozone. Muna akong pag-remember dahil antibody, siya ang una, B. So, siya ang nasa Prozone, daghan siya. And then, of course, sa Postzone, ang next, antigens. Mas daghan ang antigens sa Postzone. Alright? So, ikaw mo na ipangita og inyong mnemonic if dili effective itong ako, but I'm sharing to you mine. Okay? Alright. But again, ang important thing lang yun is same sila mo cause of false negative, and ilang corrective measures. Okay? Alright, ayan. So we now go to, after this mga intro to precipitation, we now go to the measurements of precipitation. So how do we measure precipitation? And in a way, these are also a type of mga immunoassays na din. Alright? In detecting diseases and all that. Alright, so we'll start first with light scattering. So we measure we measure the amount of light that is scattered. Okay, first is of course turbidimetry, and letter B is nephelometry. All right. Number 2 is passive immunodiffusion, meaning we use now here mga agarose gels, all right, agar gels, but it's only passive. So when you say passive, walay electricity or walay external factors or measures that are introduced into the test medium, okay, para mahitabo ang reaction. Ang passive immunodiffusion is sila mismo ang mag-diffuse to each other para mahitabo ang reaction. Okay? Alright, so that's example radial immunodiffusion, and the second is the octerlony. Alright, I don't know how to really pronounce it. I think it's octerlony or ouch. Some pronounce ouchterlony, but I think it's wrong. It sounds wrong. Sorry. I think it's I pronounce it as octerlony double diffusion. Alright. And the last one is of course electrophoretic techniques. So by the name itself, it uses electrophoresis. All right. So you have rocket immunoelectrophoresis, you have immunoelectrophoresis, and lastly is the immunofixation electrophoresis. So we'll go individually sa kanisila. All right. So are you liking the presentation so far? Ganan kay ko as in, the best ni Sir Jemu. As in, nice yung kayo as in. And nice po ang color scheme. I love it so much. All right. Okay. Ayan. So makagana mag-usog to if siya mong handout. No, oops. No shade to other subjects. Okay, all right, ayan. So first is light scattering. We'll start first with turbidimetry. So by the name itself, it measures turbidity or the cloudiness of a solution. So what it measures is reduction in light intensity due to reflection, absorption, or scatter. So because of turbidity, diba, so as you can see, guys, some of the concepts here are derived from basic chemistry, basic physics, which physics I don't like. All right. So example, you have a test tube and there's light here. An example, turbid ni siya. So therefore, the light here could be scattered or it could be absorbed by the solution, or it could be reflected. Okay? So what it does, wala na yung light, mugamay ang light na ma-transmit, okay, sa solution. So muna siya itong i-measure. Okay? Alright, ayan. So absorbance units, diba? That's in your chemistry, same siya with spectro. Alright? And yeah, spectrophotometer or automated clinical chemistry analyzer. So ang point lang is, if of course, mas turbid ang sample, meaning mas daghan imong antigens, mas daghan imong antigen antibody complex, therefore, mo-decrease po imong turbidity. Decrease imong light na ma-absorb, therefore, increase ang concentration. Naget lang? Alright. So diba, we have a spectro here. So since decrease man ang light na ma-absorb sa imong spektro, what it means is that taas ang concentration sa imuhang either antigen antibody diri. Because again, turbid man. So meaning daghan na kaayong antigen antibody complex diri. Alright? So inversely proportional siya. So if less ang absorbed light, mas increase ang concentration. Because again, nganong less ang absorbed light, turbid na kaayo diri, meaning daghan na kayong antigen antibody complexes na itabo. So therefore, less ang absorbed light, that indicates that the concentration of whatever is naa diri, taas. Okay? Gets lang? So if gamay ang concentration diri, so dili kayo turbid, so daghan ang light na ma-transmit, okay? Daghang light po nang ma-absorb, okay? It means that the concentration is low. Kay gamay raman ang complexes na naitabo diri, kay dili man turbid. Gets? I hope na gets lang. Alright? Okay. Ayan, that's turbidimetry. Alright. So medium is liquid or in solution. Alright. Next, we go now with nephelometry. Ang point sa nephelometry, di ba? Ang turbidimetry kay one way ang pag-transmit sa light. Ang nephelometry kay once pag-igo sa light sa solution, na ay different angle. Okay? Scatter ang light at a particular angle from the incident beam, meaning kung asa siya gikan, as it passes through the suspension. So what it does, okay, so again, same drawing, alright? So we have a test tube, incident light or incident beam kung asa gikan. So turbid ang sample, okay? Ang light kayang scatter, so at a different angle. Ayan, may ana. Alright? Okay. Okay. And the recorded values, light scatter as relative light scatter or extrapolated. Yung siya extrapolate, so mga chemistry, into mg per dl or IU per ml. So nephelometer measures light scatter at angles 10 to 90 degrees. So na picture later on how it does. So it's actually wide angle 10 to 90 degrees. All right. And the solution is liquid, still the same. And it's sensitive than turbidimetry. Why? Because again, it measures different angles, no? So it can capture a lot of light scatter. Whereas ang imuhang turbidimetry man good, katurang kanira na angle iyahang gina-detect. So what if napay light din na scatter diri og diri? So dili niya makuha. So it's not that sensitive. So muna sensitive ang nephelometry. Alright? Dali siya makahilak. Charot lang. Sensitive. Okay. Nephelometry can be used to detect either antigen or antibody depending on sa imuhang ganang may tabo. But it's usually run with antibody as a reagent and ang unknown kay ang antigen. Okay. Alright. But it can be used either antigen antibody, but generally or usually daw ang unknown ang antigen and then ang antibody imuhang ginatest or imong reagent. Alright. So applications, pwedeng quantification of immunoglobulins, your antibodies, and the light chains, and other serum proteins like your complement components, CRP, and several clotting factors. So we'll discuss CRP and I think some complement yata soon. All right, okay. So here is an example of parang a diagram, no? So this is your light, your cuvette, no? For turbidimetry, as you can see, usara gid siya ka angle, no? So muna siyang dili siya sensitive kay what if pagpasa light diri ni scatter ang uban, so dili na to makuha sa detector kung turbidimetry. Kaya usa naman siya ka angle. Whereas for nephelometry, pwede siyang diri na angle, pwedeng diri. Alright? Pwedeng right angle light scatter, right angle, or pwede siyang kaning forward light scatter. Alright? So it could be of different angles. So mas makuha niya ang light, no? Different light na mas scatter. Alright? Okay, that's 4 light scattering na methods in measuring precipitation. Next, we go now to passive immunodiffusion. Again, by the name itself, passive, no, you let them be. So sila nag-ibahala or sila nag-react by itself. You don't introduce mga external measures like electricity or whatever. Alright? Ayan. So first is, again, it uses now a support medium as mentioned, using a gel ba or agarose for the demonstration of antigen-antibody precipitation. Because again, by the naked eye, dili na to makita ang reaction. Because again, it could be small, no, and soluble silang duha, meaning in solution. So for us to see the reaction happening, or there's really reaction that is happening, we incorporate them into gel or agarose ba. All right, ayan. So again, occurs by means of diffusion, and as mentioned, no electrical current is used to speed up the process. So sila rang duha. So unsa may general disadvantage ani nila, it's dugay. Okay, it can take days. All right, ang passive immunodiffusion. Kaya mo naman silang pasagdaan. All right, okay. So medium is 0.3 to 1.5% agar or agarose, stabilizes diffusion and allows visualization of precipitant bands. Now I'm not wala ko ka-ask though if it's the same na itong ginagamit for culture media sa bakte. But I'm pretty much sure na dili. Okay? I think different ni siya na agar pod. I think it's, yeah. I think, pwede siguro ang nutrient agar. But wala ko ka-ask lang, no? Wala ko ka-search kung unsa na agar yun. I'll try to read on it. But I'm pretty sure yun na dili siya katong ginagamit na to for kagaw. Yeah, kay, that's, yeah. Yeah, that's not, it could interfere with the test. Alright, okay. Ayan. So agarose is preferred to agar because agar has a strong negative charge while agarose has almost none. Okay, so agarose good atong preferred kay the agar has a strong negative charge which can also affect the direction of the reaction or the reaction mismo. All right? Okay. Ayan. So some factors affecting the rate of diffusion. So start with size, temperature, gel, and amount of hydration. For size of particles, example, it decreases the rate because of course, come to think of it, dagko ang particles. So maglisod sila og pass through sa imuhang agar or maglisod sila diffuse. Therefore, decrease good ang rate. All right? For temperature, if example, taas ang temperature, it increases the rate because again, it agitates your molecules, your particles. So mas mo agitate, mas paspas silang mo diffuse sa imuhang medium. All right? Gel viscosity decreases the rate. Why? Because again, if kanang thick na kay imuhang gel, di ba? Viscous. So thick ang iyahang ano. So of course, maglisod siya pag pass through imong particles, maglisod siya diffuse. Alright? So muna mo decrease ang rate. And lastly, amount of hydration increases the rate because again, water facilitates the diffusion, di ba? If na water, if na liquid, mas mo pass-pass siya. Alright? Okay, so in a nutshell, muna siya ang parang rationale why it increases or decreases the rate of diffusion. Alright, okay. Ayan. Now we go now to the first type, which is what you call your radial immunodiffusion. So, it was discovered by James Odin, and he pioneered the techniques known as single diffusion. So when you say single diffusion, na ay tube, na ay agarose, all right? And then your gel mismo, kani siya na naisulod na antibodies daan. And then what you do is the sample or antigen, imo siyang ibutang sa taas. Alright? Alright. Now, if the unknown antigen is specific or kaning antibody na known is for that antigen, so mo diffuse sila, no? And they form, ayan, a precipitin band. Alright? If they are of the same specificity, alright? Or if they react together, they form a precipitin band. And the distance is proportionate to the amount of antigen present. So if mas daghan ang antigen, alright, so of course, murag mas layo siya diri. Alright, so ang distance is proportionate to the amount of antigen present. So proportionate siya. So if mas daghang antigen, mas layo ang distance. Alright, if gagmay ang antigen, mas duol ra sa surface. Alright? Ayan. Okay, that's for single diffusion. So it started there. Alright? Single diffusion lang. Alright, that's pioneered by James Odin. And now we go now to radial immunodiffusion, which is a modification of the single diffusion. Why is it radial? So you have a gel in ani, usually square. So the gel contains, again, the antibodies. So your unknown here is your antigen. So you put a well. So magbuho ka or magbutang ka o depression sa tunga. Alright, and then you put your antigen there. Or so what it does is mo diffuse sila outside, alright, outwards, therefore forming a ayan, radial, precipitin ring in the shape of a radius, a circle. So muna siyang radial ang name sa test. Alright? Okay, that's a precipitin ring. And as the antigen diffuses out from the well, the combination occurs in changing proportions, okay, until the zone of equivalence is reached. Alright. So of course, paggawas antigen, of course, na yung mga ginagmay na reactions mo occur until maabot nila tong zone of equivalence, alright, and then forming na a precipitin ring. Alright, which is in the form of a circle. Muna siyang radial ang name sa test. Alright. Now we have different techniques for measuring radial immunodiffusion. You have the Mancini method and the Fahy and McKelvey. Alright, so ayan. So first method is the Mancini. This is known as your endpoint method. And the Fahy and McKelvey is known as the kinetic. Alright, so Mancini is, ang point niya is endpoint man. So measurements are taken. So i-measure nimo ang radius, ang diameter sa circle, at the end point of the reaction, meaning imo na siyang i-measure pag naanay makitaan gyud na precipitin ring. Alright? And whereas, ang kinetic method, wala pa lang naabot ang zone of equivalence or wala pa yung precipitin ring na nakitaan, nag-measure na ka. Alright? Ayan. So therefore, ang Mancini is quite longer, 24 to 72 hours, whereas ang Fahy, McKelvey, it's only 18 hours. Alright? And how you determine the concentration? D stands for diameter. So diameter of the circle man ang na-form na precipitin ring, diameter squared is equal to the concentration of the antigen. Whereas for Fahy and McKelvey, the diameter is equal to the log of the concentration of the antigen. Alright? So as you can see, diameter, dili na siya squared, no? So because again, wala pa naabot ang sana precipitin ring, nag-measure na ka. So you take the log. Alright. Okay. And yes, see, I'll share the mnemonics later. All right, okay. So some applications of radial immunodiffusion, measuring your IgG, IgM, IgA. An advantage is simple to perform, requires no instrumentation, and a disadvantage is fairly expensive to run. All right, sources of error, as you can see, overfilling or underfilling the wells. Yes, if gamay ra kaayo or daghan kaayo, so it could affect the reaction. Nicking the side of the wells when filling, so meaning matouch ang side, no? So pwede nang maka-introduce na kaday ng antigen, wala pa nag-start ang test. Spilling sample outside the well, still the same reason. Improper incubation time and temperature, still the same, no? Diba? The factors that can affect the rate of diffusion. And lastly, incorrect measurement. So kung unsa man, if Fahy, McKelvey, or Mancini. So I have a mnemonic for that. You have FKME. So how do you pronounce that? I won't pronounce it. Okay. So FK-me. So me. Okay. All right. So Fahy, McKelvey is kinetic. Mancini is endpoint. All right. Very helpful, guys. Diba? It stuck with me until sa third year pa ko na-introduce ani na mnemonic. It stuck with me until now. So FK-me. Me. All right. Pero po like frick me or if ikaw, ganahan na siya, i-pronounce it naman, no? Dira ko mo pronounce kay public ni siya in YouTube, so basin maban ko. So, me. Alright? So, Fahy, McKelvey, kinetic, Mancini, endpoint. Alright? Okay. Now, for the next video, we'll continue with passive immunodiffusion with Octerlony double diffusion. Alright.